Okay. So recommended nutrient intake or RNI. So the learning outcome for today is to describe what is recommended nutrient intake. So I think most of you are familiar with RNI. Second one is to define what is the estimated average requirement, EAR, recommended nutrient intake, RNI, adequate intake, AI, there's a spelling error there, and upper level intake, UL. And finally, we need to explain the uses of RNI. So nutrient recommendation differs with age, sex, and physiological condition. So different age will have different nutrient needs and their recommendation. Similar goes to the sex, gender, and also physiological condition. So this is the distribution of energy requirement of a population group or class or individual. So when you tabulate them in a graph where the y-axis is percentage of, y-axis is the percentage of individuals and the x-axis is the level of requirement from low to high. So this is for energy. When you tabulate a graph like this, you get a Gaussian distribution where in the middle is the average, and then you can identify the middle one is the average requirement needed by that group or class of individuals. So this is assumed that individuals' requirement are randomly distributed about the mean requirement of the class of individuals, and the distribution is called Gaussian distribution. So this graph shows the probability that a particular energy intake is adequate or excessive for an individual. So when we say individuals, so individuals in this discussion is randomly selected among class of people or a population group. So this is not everyone, but they are randomly selected. So the two probability curves overlap, where we can see that here it overlaps, so that the level of energy intake that assures of low probability of dietary energy deficiency is the same level. This is the low probability of dietary energy deficiency is the same level that implies a high probability of obesity owing to dietary energy excess. So it is up here. So the average requirement should be in the middle, okay? And this graph shows the risk function of deficiency and excess for individuals in a population related to food intake, assuming a Gaussian distribution of requirement to prevent deficit and avoid excess. So we can see that these are the criteria to define requirement. And this is the risk of deficit, a risk of excess. So y-axis is total intake. So lower intake means risk for deficit, and higher intake means risk for excess intake. And these are the cumulative risks for disease. So EAR, RNI, and upper level is considered to be in the acceptable range of intake. So we will see what is EAR, RNI, and UL upper level after this. So the shaded range correspond to different approaches to defining requirement to prevent deficits and excess. Okay, so the estimated average requirement, EAR, is the average daily intake required to prevent deficit, okay, in the half of the population, of 50% of the population. And the recommended nutrient intake, RNI, is the amount necessary to meet the needs of the most of the population, around 97 to 98%. That's 97.5 to be exact. And RNI is set as the EAR plus 2 standard deviation. Okay, how do we get RNI value? It's EAR plus 2 standard deviation. And then the tolerable upper intake level, UL, is the level of which no evidence of toxicity is demonstrable. So we can see that The cumulative risk for excess is 0 here, and this is set as upper limit. Okay. So this figure shows us what is actually, where is EAR, RNI, AI, and upper level. So we are going to explore each term one by one. So EAR here, okay, let's look at the graph first. The y-axis is risk of an inadequacy, and the x-axis is observed level of intake, okay, from 0 to higher level of intake. So here is risk of excess, here is risk of inadequacy. So EAR is the median intake value that is estimated to meet requirement in half of the individual in a life stage of sex group. So around 50% of the risk of inadequacy is targeted at EAR. Okay, whereas RNI around 97.8 or 98% achieve the required nutrient, and the risk of inadequacy is just around 2% here. Okay, so that is RNI. So the next slide will show you the definition of RNI. RNI, average daily dietary intake level, that is sufficient to meet requirement of nearly all healthy individuals in a particular life stage. So this must be according to specific life stage and gender, okay, and nearly all healthy individuals in a particular life stage and gender group. So RNI is equal to EAR plus 2 standard deviation to cover almost 97% to 98% of the individuals in the group. And how about AI? AI is based on the experimentally derived and intake levels of approximation of observed mean nutrient intakes by a group of apparently healthy people who are maintaining or defined nutritional state or criterion of adequacy. So AI is adequate intake. It can go up to upper level intake here. Okay. And finally, upper level or tolerable upper level is the highest level of continuing daily nutrient intake that is likely to pose no risk of adverse. So if we go a little bit higher from the upper level intake, you have risk of excess here. So basically the risk of excess here is 0. So if we go more than this, more than the upper level, tolerable upper level limit, you'll have risk of excess. Okay, so we have covered the definition of EAR, RNI, AI, and also UL. So in determining the RNI, we use standardized age categories and reference weight. So we have for the Malaysian population, RNI, this is the age group and also the reference weight used in when developing the recommendation. Okay, so for all age categories, the ending age extends till just before the beginning of the age of subsequent category. So you can see that 3 months until 5.9 months, and then the next age category start at 6 months. Okay. And children for age 0 to 9 here, 0 to 9, it's based on WHO weight for age median, and for adolescent 10 to 18 years, it's based on mass equivalent of WHO BMI for age median based on the NHMS 2015 median heights. Okay, and for adults, mass equivalent to BMI 22 based on the NHMS 2015 median heights. So all the body weight is based on the height that is set based on the data that we get from WHO NHMS 2015 for adolescent and NHMS 2015 for the adults. So basically these are the median heights used, So we set for adults, we set the BMI first, 22, and then we calculate backwards to the body weight. So these are the standardized body weight when we calculate RNI for each nutrients. So in RNI 2017, so previously we have RNI 2005. So you can read in the RNI book, which I'll give the PDF copy. You can also buy from Nutrition Society Malaysia. The RNI book is only 55 ringgit, if I'm not mistaken. So but you will have the PDF copy. So the nutrients reviewed in RNI 2017 is as shown in the slide. So you have macronutrients and energy. So you have energy, protein, fat, carbohydrate, and then you have all sorts of vitamins, B1 until vitamin A, D, A, K, and you have minerals and trace elements from calcium to fluoride. Okay, so these are all the nutrients reviewed in the RNI 2017. Some have been there in 2005, some have been added. Example is copper, manganese, molybdenum, fluoride is added new nutrients in RNI 2017. So what's new actually in RNI 2017? The reference body weight for adults are now calculated based on the desired BMI of 22 and average height of the Malaysian population. So previously, the reference body weight was just the median body weight of the population. So what will happen if we use the median body weight of the population, since currently the median body weight is higher due to obesity and so on. So the requirement set will be higher. So and then when it's higher, it means it will be in excess of intake. So that is the reason why this in 2017 we set the desired BMI at 22 for the average height of the Malaysian population. Number 2 is the estimated energy requirement are based on physical activity levels. Okay, this was not done previously, so this is new. And for energy requirement of infants, there are 4 age categories. There is 0 to 2, 3 to 5, 6 to 8, and 9 to 11. So this was not there before. Before this, it was lump sum together as infants. And there are 9 new minerals and 4 new vitamins added in this report. I'd like to explore what are the new minerals and vitamins later on. And the age categories differ slightly from the minerals group when compared to the energy and macronutrient and vitamin group. So why is the reason is because we do not have data on the minerals intake, so we have to adopt from other recommended nutrient or recommendation outside. So we have to follow the age group in the recommendation from outside countries. Okay. So these are the uses of RNI. So we're already reaching towards the end of the lecture. So these are the uses of RNI. So there are 5 uses of RNI. The first one is policymaker, for policymaker. Second one is for program planner. The third one is for food industry. Fourth one is for clinical practitioner usage. And finally, for research purposes. So for those who have not seen RNI before, this is the front cover of RNI 2017. So the first use of RNI is for the policymaker, for them to plan and monitor the national food supplies and stockpile of foods for emergencies. So if you do not have a guide, what is required, we cannot plan and monitor the food supplies for the country. It is also used as a basis for development of national dietary guidelines. So after we develop recommended nutrient intake, we have to develop national dietary guidelines like what we are doing now. In 2020, we are updating the Malaysian dietary guidelines. Okay, so And also policymaker uses RNI as a reference for development of relevant policies in terms of example is agriculture policy and so on. So RNI is very important for policymakers as a guide for them in planning new policies in future. The second group that needs RNI is the program planners. So they use RNI to evaluate the dietary intakes for the population and also for the specific identified group that they are interested on. And they also ensure the adequacy nutrients in food intervention program using the RNI. So if you have a guide, so we know whether the nutrient is adequate or not. Program planner also use RNI as a reference in the development of educational materials for nutrition promotion. Okay, so then we know that how many milligrams of vitamin C is needed, and then they can develop education materials and so on. And finally, to identify risk of inadequate nutrient intakes for certain groups. So program planners also need to identify who are at risk for this nutrient inadequacy. So they do that based on the RNI. The third group who uses RNI is the food industry and marketing groups. So they use RNI as a reference for nutrition labeling of foods and supplements. So when you look at the label we have, they have their content of nutrient in the product, and also they compare with the RNI, how much of the daily RNI is achieved. Okay, and they use as a guide for nutrient claims on food products. So when they want to claim is high source of protein, high source of calcium, so they use RNI. And finally, for food product innovation and food fortification, so they need RNI so that the product doesn't exceed or deficit the requirement needed for specific nutrients. Number 4 is clinical practitioner. So they use RNI to assist in development of therapeutic diet manuals and assessment of individual diet. They also use for plan modified diet and plan procurement for food supplies and manuals for hospital or institution. So most of the time, they don't exactly use the RNI because they have their own calculation, but RNI is used as a guide to see whether the calculated value is around the tolerable upper level or above the EAR intake. And the final group who are interested to use RNI is the researcher. So researchers use RNI as a main reference for dietary analysis of epidemiology studies. So when you do research, you want to compare, you'll be interested to compare the nutrient intake of the population, whether they achieve some level of intake or not. So the level that they use is RNI. So they also use RNI to evaluate nutritional quality of foods by calculating the nutrient density index. So nutrient density index is a in thing now. So they use RNI to calculate the quality of the food. For each food, they will have the nutrient density index value. So I think this is the last slide for RNI. So RNI and chronic disease. So as I have mentioned before, RNI can also be used as a guide to reduce risk of chronic diseases, and the suggested target of nutrient intake in order to reduce risk of chronic disease is equivalent to 90th percentile of population RNI. So if a group of population achieve 90% of the RNI is considered, it can be reduced. It can reduce risk of chronic diseases. And energy requirement was set using body weight and BMI of 22 because in relation to increasing prevalence of NCDs in Malaysia. So we know that 1 in 2 Malaysian population have higher risk, overweight or obese. So we do not want to set more or higher requirement, and then there will be excess intake, especially for energy intake. So the revised energy requirement is actually lower than RNI 2005 when we use the new approach of PMI 22. So the energy requirement is reduced by 8 to 18% for adolescent and also adults. Okay, so do you have any questions so far?